Hello student, okay, welcome back to our class for the third video of the day. Okay, when n is not a positive integer, so what we should do for binomial expansion? Okay, so first, okay, you need to make sure your a is always 1. Okay, if your power is not a positive integer. If the power is a positive integer like the previous example, example 2, example 1, okay, you no need to make sure a is equal to 1. Okay, so when your a is equal to 1, so this is a formula, right, to expand. And then as your information, the number of terms for this expansion will go to infinity. Right? So it's different from the positive integer whereby you have a fixed number of terms. So for not a positive integer, it will go on forever. Right? So how to get each one of these? Right? So very simple. So since your a is 1, the first term is always 1. Okay? Then the second term, okay, will be n times the b. So for third term onward, so this one is b power 1, okay, b power 2, b power 3. Right? Same concept as the positive integer. The b is increasing. Okay, so since a is 1, right, any power to 1, right, will also getting 1. Right? So that's why we want to, right, make sure the a is 1, right, so that the expansion will not involve any a, right, for the following term. And then for third term onward, okay, you have to form like this. Okay, n minus 1 over 2 factorial, right? Okay, how I know it's 2 factorial, how I remember? So I just look at how many number of bracket multiply. So 1, 2, so 2 factorial, right? So for this term, for example, right, so you have 3 brackets, so n minus 1, n minus 2, so 3 factorial. So I can also go on for b power of 4, okay, whereby you have n minus 1, n minus 2, n minus 3, okay, so you have 4 brackets, so 4 factorial. So I can also go on to b power of 6, okay, b power of 6 will be n minus 1, n minus 2, n minus 3, okay, n minus 4, okay, n minus 5, okay, so I have 1, 2, 3, 4, 5, 6, okay, so I have 6 brackets, so over 6 factorial, like that, right, and so on. Okay, so in order for this series to be convergent, okay, to be valid, right, then another things that you have to remember is your b must be in between -1 to 1. Okay, so I will further explain this by using example. Okay, let's go into example 3. Okay, so your a is always 1. Okay, your a is always 1, and then the power, right, the power is not a positive integer, it's a negative. Okay, so the question will ask you to expand this up to a certain x power. So for this question, they ask you to expand expand until x power 3, right? So that's why we stop at x power 3. Okay, so we use what we have learned just now. So first term is a, okay? Second term is n times b. Third term will be n minus 1 over 2 factorial b squared. Okay, third term will be n minus 1 n minus 2 over 3 factorial b cubed. Okay, so after you expand, the question also want you to find the interval where this expansion will be valid. So we remember that, you need to remember that, right? Your negative, your b must be from negative 1 to 1. Right? So two things I want you to remember. Right? The first thing is you have to make sure the a is 1. Okay. Second thing, in order for the expansion to valid, the b must be in between negative 1 to 1. Okay. And beside that, you also need to remember the expansion formula. Okay. So I already teach you how to remember it easily. Right? Yeah. You just okay, one way, okay, you just refer to the previous n, okay? So you just add n minus 1, okay? So you refer back this one, okay, n minus 1, okay, plus n minus 2, right? And the factorial, you just look at how many brackets, it will become the how many factorial. Okay, so the b is the power increasing, that's all. Okay, so question B, also same, right? The power is 1 over 2, right? It's not a positive integer. And then you see, you also make sure the a is 1, right? And then expand up to x power 4. Okay? So in order for the expansion to valid, it must be from negative 1 to 1. Okay, why I always mention about the a must be 1. Okay, so for example, if your a is not 1, okay, it start with 2, for example. Okay, power negative 1. So this 2, okay, you need to factor out, okay, by using the knowledge of your index, okay. So you can actually factor out the 2, okay. Then, okay, you can only start to do the binomial expansion, okay, from here, okay. The 1 over 2, right, you take out, okay, from the bracket. Okay, so example 4, okay, this one is a PSS question. Okay, so you are given the binomial expansion, and then they already expand for you. And if you look at the red color 1 over 100 is the one that they want you to substitute into the series. Okay, question 1 to 5 square root 2. Okay, so okay, this side you can calculate. Okay, this one you can calculate straight away, and you will get this. Okay, 0.9899495. Okay, and then from square root 49 and square root 50, so both of these, you will find that square root 50 will be able to get square root 2. Okay, so square root 49 you get 7. Okay, square root 50, okay, you get okay, square root 50, okay, you can actually get square root 25 times 2. Okay, where you get square root 25 times square root 2. So that is how you get 5 square root 2. Okay, and then okay, bring the because this is equal, so you can actually right, cross multiply and exchange this to the next number, okay, opposite number, okay, and simplify it using the calculator. You will able to get 1.41421. So that's all for this topic. So I want to encourage all of you, right, by using this quote. Okay, the study of mathematics is like a nail, begin with meaningless but end with magnificent. Okay, so from this Charles uh, right, so that's all. Okay, thank you and have a nice day.